longest path with different JSON characters. So given the tree, and when we find out that is committed and undirected graph that have long cycle greater than 0, consisting from 0 to n minus 1. And our tree represent values where index of parent and size of node. So where parent is parent node, node 0 is root. We also give the string. I also want you to find out that the longest path in the tree such that no adjacent node on the path is synchronous. OK， 我最长的 path in a tree OK， 所以这个 path 可以是一个 OK，the path can be from root to ABC, or we can say from this to string, right? So basically the same. Okay. 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 So one goes to find the longest path that characters adjacent characters it's not the same. So idea is post order DFS, and we will return that. So we want to do is to return that there's a tree, right? And let's just try to traverse from 0. We also have a node, and so we still have the maximum of the length we can do. Okay, and yeah, basically this is tree, and the tree may have many. The tree may have many. Okay, and I'll say okay, return value is the so we want to choose is okay. So basically we can say that if the child is not equal to the root child, so we can add, right? So we can add, we can choose add, okay, and then we can say yeah, so basically say this is 3, right, and this is 3, okay, because the same, but you can see the same, so we cannot do, but we say that this is 2, okay, this is 3, okay, and also I need to use a maximum answers, okay, so now answer is going to be 0, and I just traverse. And first of all, I'll just view the graph. Okay, view the tree. Want to do is view a tree. It's on the graph. Okay. Okay, that's the size here. Okay, we say graph the parent will push back I. That's a node, okay, and we still need to do is still have a string. Also need to do, okay, and build a tree that just try to update the maximum value, or we will return the maximum length so far. Okay, and you say in the graph, actually we don't need parent because and then we say we have array that is the child. Okay, so that idea is that we can say return maximum is 1. Okay, and so 0 and source maximum length so far in the local length. So if the SV is not equal to SU, that means that there is something that we can just try to, for example, say A is the same, right? A is the same, but maybe the tree is more deeper, right? So say I just try to do this. V is child answers, right? And say the child will push back the child. Okay, because and I would say consider that the answers can be maximum, right? So we'll choose sorted trials targeting trials Rn, and we just say resize about the mean to trials size. Okay, we only record 2. Okay, and if child size is equal to 2, we will say answers is going to be maximum, trials 0, add trials 1, add 1 answers. Okay, or we will say else if answers can be 1, right? Because okay, and we also return that the maximum child. Okay, and resources 1, this is return, and that is child size, return add all trials 0. Okay, this is the return. Basically, let's choose 3. Okay, that's it. Answers should always be 1. And suppose that we have empty, right? And wait, why this is 0 here, and answers is going to be, actually it's going to be 1. Okay, that's that here. And consider that there is to the integer's resize positive. Okay, and I want you to find the corner path is defined as a set with adjacent cell at most 1 term. a corner path. More specifically, the path will going to be the this problem seems like a little long. Minimum rounds to finish complete or task. So you give your task and represent a difficult level in which round you can complete either 2 or 3 or some level. Minimum rounds required 2. So basically we can say can complete 3 or 2, right? So so basically we say that there is so our goal is minimum 0, right? And each round can finish 2 or 3 tasks. And for example, say we finish 2, finish 3, we just calculate. So idea is first we just compute the consecutive task length, and actually what I want to do is if we just divide 3, and if this is mod 1, if mod 3 is going to 1, then let's use 2 to change the mode, right? So if mod 3 is 0, use 3. If mod 2 is 1, use 1, use 2 once. The mod 2 is 3, we just so the resource, let's read the approach. I just try to do that. Next, size. So you can do this. It's going to be J, and J. And the test J is equal to test I plus. And what is the length? It's going to be if length mod 3 is going to be 0, we just add length minus 3. Else if length mod 3 is going to be 2, we just use 3 add 1 because use 1. And we'll say length resource add 1 means minus about 2. And but there's a problem is if length is equal to 1, we must say that we cannot return. And that's right here. -1. Wait. So in the first round we say it's you can complete a difficult label. So you can complete and so I know that. So it's so what we want to do is what? This is 2, we just move that. And let me symbol this. basically we say we can merge this value, and after we merge this value, we say we need to use this, right? Okay, let's think about this. Okay. Oh, scientific label. That means that the order doesn't matter, so we can sort the tasks. Okay. Since note the order doesn't matter, the order doesn't matter. Okay, so we will say it's 4 and then pick 1, right? Okay, so it's 4. So 4 is minus value 2, and we use 1, 2, right? Oh, wait. Means is 8. This is 8, right? Wait. We say if this is 7, we use. If this is 7. Oh my god. Wait. Okay. If this is 7, what should we do? Is actually 1. Oh, okay. So it's minus 2. So you need to minus 4. Okay. Usually the edge case is that, right? Okay, doesn't consider edge case. We given a string that is integer and also want to around complete one round to follow, divide as into consecutive group the size of case such that first case at the first group, next director second group. Okay. So we can do is return k divide as into consecutive group of size k, such that the first k are in the first group, the second group. Notes that can be smaller. Okay, so do the following. Okay, divide, replace, and merge. Okay, so this is do something that is divide and replace and merge. Okay, divide, replace, and merge. Okay, and divide is consecutive size, merge. Okay, so return the else. Okay, so basically we just split. Actually, we can simulate a process, right? So we just use consecutive, replace each group as which represents sub the digit. So for example, we know that this is, and we first calculate the group 3, 4, string. If the length is greater than the k, we get the state 1. So I want to do is simulate, okay? So size is greater than k. Okay, string has t here. So first divide is going to be calculate string s, okay? This is calculate the digit sum, okay? And it's active, so it's going to be group, right? So we group triggers, okay? So for string 10 was and to calculate 10. That just simulate, right? Simulate zero, 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 okay? That is okay. So what is this? Maximum shading 0. So for example, okay, let's look carefully. Adjacent that moves one turn. Oh, I got idea. So basically, the path is decreasing more even horizontally or vertically up. For some path will then move these to the ordinate directions. Move vertical. Okay. The product path that I want to do is the maximum traveling 0. Oh, traveling 0. Okay, so it's maximum traveling 0. So a path that is only change direction once. Okay. Yeah, only change. Wait. It means at most one turn. Okay, at most one turn. That at most one turn. But basically, I don't understand why. For example, say horizontal is moving either left and right, up and down, vertical up and down. So if you agree, that is m minus n. Okay. M times n. Okay. So give you the agree that is going to be size. Why is the ideas? Maybe I don't know the ideas. But trading 0, we just only consider 2 and 5 count. Okay. Turn it okay. Because in this case we know that. So what I want to do is if shown as so agreed. For example, left shown valid, it has a product maximum. Middle is not a core. Oh, okay, only change once, right? Yeah, at most once. Okay. After a turn will move extremely the ordinate directions. Okay, so you only change direction. Okay, we will not change this direction. Okay, got idea. And what to do is maximum. So okay, seeing that idea is define the DP, the change or not, right? So it's the maximum so far and change or not. Okay, suppose we have a DFS here and change or not. Okay, so means that, for example, we say DP function can be like this. Okay, so we say, for example, say we can so this will be the same, right? This will be the same, this will be the same, and yeah, actually you need a DP here, just like in each we can say we can either this or this, right? In the first row, okay, and in the second row we say we can either this one. So actually only some case, okay, only some case, okay. So for example, say excluding the left, right, we say this will be either okay. So this one basically is noise, a noise, okay, noise problem. You need to consider that. Okay, zero product I found some create and even left and right directions. Vertical movement means that move up. So for example, say in this case we will say that this is only in this case here, this case or this case. So it's the L, right? It's the L. So basically we said L is going to be this case or this case, in this case or this case, this case or this case. Okay, I have an idea. So consider I have a helper functions, okay, and the helper functions, okay, and suppose that only consider L shape, okay. What means L shape? I just first we just try to calculate value of here, okay. And what I want to do is think about this. Answers is going to be helper. Okay, let's just think about only one direction and we can do either left and right. So consider that in this operation we can do either get all the terms on the right, or we can either do the left, right? So there is a prefix here and a suffix here, okay. And also I want to do is prefix and suffix, okay. And Okay, so basically we say we want to build the suffix. Okay, build the suffix here of each. Okay, for each j, we're going to build suffix here. What is that here? Okay, build suffix. Okay, and excluding this pass. Okay, so basically we say this will excluding this pass here. And the maximum so far of the L shape. Okay, so we still have here that is the so far. Okay, the shape. Okay, from top to current row. And I have right there. Okay, so basically we say do is calculate the number of the LMR since well x more 2 okay. That is right here. This operation is very slow actually. Okay, so far, right? So far over 10 to calculate the grid. So far second will add about 10 seconds. This is the so far function. Update so far, and update so far is it's from we update so far first, and actually what I want to do is just from left to right, just calculate it. Okay, excludes the positions, right? So that means a suffix here, suffix we have n. Okay, and for it's -1, j is greater than 0. Okay, suffix back is going to be calculated only in the row. So is grid -1. Okay, calculate the row. Okay, calculate the row. Yeah, and total 10 is going to be calculated grid -j. Suffix j is going to be the suffix j first add 10 first. J -1 suffix j second add about 10 seconds here. Okay, now we have the idea is that, for example, say that so far, this is prefix, okay? And prefix will include this crew number. So resource is going to be the so far. Okay, let's just count, okay? The total count is going to be the so far first. So far, take it at the first. So prefix first. This is operation 1. We have prefix. This is the what means shape like this, okay? Okay. And yeah, after that, I'm just lazy. Only the shipment count part first. 就说我们最少需要几次，有几次2这样子。那这是选择1，选择2的话呢，基本上就是几次，这个就是所有的表现。Okay. And count 2, we will add so far add about the suffix. So far 这个东西是，没错。That's it. Okay. 下个东西。So fast, okay. Okay, so this problem is very classic problem, and you just try to do from bottom to the root, and this 3dp here. And basically the idea is that for each node, and we record a child, if the character is not equal to the current node, we will push to our candidate. Okay, and we sorted from the big to smallest and only record 2. And actually we just try to do is that basically we can say if the child size is 2, we only pick about the first string or 0. Yeah, so this update our maximum, and the return is that we just return the topmost value, because basically this is only record 3 and this is only record 2, and we will pass to the parent like this. Okay, that's very classic. Okay, yep, and that's problem B. And for this problem, you need to consider the left position and right position and the build of suffix. And actually you only need to consider the shape of L. Left L or right L, and you can use prefix sound technology. And actually you just use L shape maxima, so it's like current so far accumulate, and for each row we just try to do this L shape or this L shape or this or this or this or this or this or this or this. Okay, so you will see that this the suffix build suffix here, and the so far and the prefix we only have the 2 candidates, the L shape. Going to the left, we just record maximum. Going to the right, we just record maximum, and that's it. Okay, and we just reverse because we came from the bottom L shape. Okay, so we just reverse. We just do the same things. We can get an answer. Yeah. Okay. And what about question number? This problem. Okay, this problem need to care for that because we can choose the same typical label. That means that you don't need to choose the adjacent task. We can choose. We just record. We can sort and then count the record of the same thing. And actually, you can use another method to do that. But yeah, and edge case is that if the length is 1, the more value is 1, we use 2. Actually, we use twice 2, right? Two times. Okay, and just care for that. Okay, because the 4 value we cannot use 3 1, right? Because we must use 2 and this is greedy, only an edge case. Yeah, just care for that. Okay, and that's it. That's a problem. And for this problem, just simulate a process and try to divide and replace and merge. Just try to simulate it and update. Just do as a problem state. That's it. So yeah, that's a problem. Okay. Interesting.